Now on to objective 3. So objective 3, we want to solve problems involving vertical angles and straight angles. So the figure to the right here, what we see are arrows that are crossing each other, and we have marks 1, 2, 3, and 4. So we're saying that the figure to the right, this figure, shows two intersecting lines forming angles that are numbered 1, 2, 3, and 4. So each one of our numbers represents an angle. Angles 1 and 3 lie opposite from each other, and these are vertical angles. So 1 and 3 are opposite, or they are across the cross. So these are called vertical angles. 2 and 4 are also vertical angles. And the important thing to remember is that vertical angles have equal measurements. So they will be equal in whatever measurement that they are. Angles 1 and 2, when added together, are going to equal 180. So we're saying that 1 and 2 will equal 180 degrees, and that is because 1 and 2 are on the same line. So they're equal to 180 because this is like saying that we have half of a circle. And when you cut that half of a circle in half, so into some form of quarters, you're going to end up splitting that 180 degrees in half. Well, okay, not in half. You're splitting it into two parts. So 1 and 2, when you add those, or angles 1 and 2, when you add those together, are going to equal 180. So they're not equal to each other, but when you add them, they're equal to the set value of 180. So we can draw a little plus here. Plus. We also see that our other pairs of straight angles are going to be 2 and 3, 3 and 4, and 1 and 4. You can kind of highlight these as well. So 1 and 2, 2 and 3, 3, 3 and 4, and 1 and 4. So we add those values together. And these are called our straight angles. So main differences to remember: vertical angles are equal to each other in whatever angle degree they are. Straight angles, you add them together to equal 180. So those are the key things to remember. In example 3, we want to find the measure of the marked angle. So we have 3 marked angles in this case. We're going to say that 4x plus 19 is 1. 10x minus 7 is 2. And 6x minus 5 is going to be 3. And we actually have 2 methods in order to solve all of our angles. And what we're doing here is that we're just solving for x. But there's 2 different ways we can go ahead and solve for x using the definitions of our straight and vertical angles, which we just learned. So we're going to go ahead and start with method 1. And our method 1 is going to use vertical angles. I'm actually going to scoot this over though. So method 1 uses vertical angles. We determined that vertical angles are equal to each other, and our vertical angles in this case are 1 and 3. These are our vertical angles. So 1 and 3 are equal. This means that our equations or our expressions are equal to each other, making one equation. So we're saying that 4x plus 19 is equal to 6x minus 5. So we're setting these terms equal to each other. We're setting these expressions equal to each other now. And now we just want to solve normally. So when we have a problem like this, we're going to go ahead and we're going to add 5 to both sides. So I'm going to say 4x plus 19 plus 5 is equal to 6x minus 5 plus 5. (19 plus 5 is going to be 24. And now we just have 6x. We want to isolate all of our x terms to one side, so let's subtract 4x from both sides. This will give us 4x plus 24 minus 4x is equal to 6x minus 4x. So now on our left-hand side, we just have 24, and 6x minus 4x is just 2x. And we're solving for x, so we're going to divide. We divide by 2 on both sides. So now we have our single x. Sorry, our x is on the left-hand side in this case. Doesn't matter what side your variable is on. I do have a tendency to really like to put it on the left-hand side. You can have it on the right-hand side if you'd like. It means the same thing. So 24 divided by 12 is, 24 divided by 2 is going to be 12. So we have x is equal to 12. So we've solved for x in this case. And this was one way to solve here for our vertical angles. So we can go ahead and we can just go ahead and check to make sure that this is correct. We want to make sure that angle 1 and angle 3 are equal. So we're checking. We're plugging in 12 into angle 1. So this here is angle 1. We're going to get 4 times 12, which is 48, plus 19. And 48 plus 19 is going to be 67. So 67 degrees. Then our angle 3 was 6 times 12 minus 5, where 6 times 12 is 72. And 72 minus 5 is 67 degrees. So our angles are equal to each other, and we've now solved for our angle measurements of angles 1 and 3. So we can say that these we now know are, let's put little angle signs here, 67 degrees, little angle sign, 67 degrees. Let's see, we don't know our angle for angle 2. Now we can easily calculate angle 2 by subtracting 67 from 180. So we can say from this point, we can subtract either angle 1 or angle 3 from 180 degrees to get angle 2. So we're going to say that angle 2 is equal to 180 degrees minus, let's just go with angle 1, which is equal to 180 degrees minus 67 degrees, which is going to go ahead and give us 113 degrees. So we've gone ahead and we've found the angle measurement for each one of our angles. Now, I want to go ahead and do method 2. This is method 1. Method 1, we started off calculating our vertical angles. Now we're giving this angle, and we're saying it's 113 degrees. But now for method 2, we're going to start off using straight angles instead. So in this case, 1 and 2 and also 2 and 3 are all straight angles. So we're going to pick our angles here. We're going to say angles 1 and 2. And we know that 1 plus angle 2 is going to be equal to 180 degrees. So we can go ahead and we can add our expressions. Angle 1 is 4x plus 19. And angle 2 is 10x minus 7. And we're saying that this is equal to 180. Combining our like terms, 4x plus 10x is going to be 14x, and 19 minus 7 is just going to be 12. And now we want to solve. So we're going to subtract 12 from both sides. This will give us 14x is equal to 168. And we divide both sides by 14, which gives us that x is going to be equal to, I lost my lost my marker at this point. X is equal to 12. So in both cases here, we got x equals 12. So whichever way that you choose to do these problems, you should get the same answer, which we found that x was equal to 12, but in this case, we know that we want to check and make sure. So we can plug 12 in to our original equation, which was 4x plus 19 plus 10x minus 7 is equal to 180. So we had here, this was angle 1 and this was angle 2. We know what 4 times 12 plus 19 is because we did it in our last problem. It's 67 plus 10 times 12 is going to be 120 minus 7. And we add these values, we get 187 minus 7, which is equal to 180. And then if we picked this method, the only thing we have to do in this case is just see what our angle 1 was equal to. So since we know that angle 1 is equal to angle 3, this tells us that angle 3 was equal to 67 degrees, because we would have calculated our angle 1 in this case. Or we could also, once again, subtract what we know to be angle 2 from 180. So we could subtract 113 minus 80, which would give us 67, which would give us our angle 3. So these would be two separate methods you could choose from when calculating in calculating angles. And in this case, we were able to choose because of the problem we were given. But remember, if your equations are opposite or they are vertical angles, you do have to set them equal to each other. And if they are straight angles, you do have to add them and set them equal to 180. You wouldn't have the option in that case to choose one or the other if you don't have both. All right, so last objective, we want to solve a formula for a specified variable. So sometimes we need to rewrite a formula in terms of a different variable in the formula. If we would like to solve for another term in our equation, we can always rewrite our formula in order to have whatever we're solving for isolated by itself so that we can easily just plug in our values and calculate away. We wouldn't have to do any sort of dividing or anything like that. So the process in which we do this is called solving for a specified variable or solving a literal equation. To solve a formula for a specified variable, we use the same steps that we use to solve an equation with just one variable. So when we work on these problems, where we're rewriting or solving for these specified variables, what we're really doing is we're going to work in a more theoretical way. So we're going to work with the concepts that we're using, and then we can go ahead and plug values in. This just meaning, and as an example, if we have terms such as ax plus b is equal to c, we would do everything we can in order to find whatever our variable is. So in this case, with ax plus b is equal to c, in this case, we're solving for c. We're saying c is equal to this equation. And then we go ahead, we subtract b, we get ax is equal to c minus b, we divide by a, and now we have that x is equal to c minus b divided by a. So now we're solving for x, solving for a different value in our formula. So all you're doing is rewriting an equation to solve for a different variable. That's all you'll be doing when you want to solve for a specified variable. So when we solve a formula for a specified variable, we treat the specified variable as if it were the only variable in the equation and treat all other variables as if they were constants. So we're going to treat every other term as constants when we want to solve for one specific variable. On to our last example here, example 4. We want to solve for area is equal to length times width for the width. So now instead of having area equal to length times width, we want width to be equal to something in terms of area and length. So we can go ahead and say that. So we want an equation that gives us a relationship for width in terms of area and length. So if we want to solve for width in this case, and we're treating now area and length as constants, we can go ahead and solve for this equation like how we would any other equation. So we want to divide out our length. You're going to have area divided by length is equal to length times width divided by length. And since we have length in our numerator and our denominator on our right-hand side, we get that area divided by length is equal to width. So this is now our relationship of width in terms of area and length instead of just area, or our relationship of area in terms of length and width. So we solved for a different variable in this case. So, all right, I will see you all again for section 2.7.